This is my final exam performance assessment, and I'm going to be doing problems 1, 2, 4, 5, and 14. The first problem says, in response to the question, if a fair die is rolled twice, what is the probability of rolling a pair of fives? A student replies 1/3 because 1/6 plus 1/6 equals 1/3. How do you respond? I would tell the student, well, instead of telling them, I would show them because I think it's easier to see it. So I would go through and draw all of the possible outcomes from rolling 2 die. So I would start with doing all of the ones, which would be it would be 6 ones with each number on the die. So 1, 2, 3, 4, 5, and 6. And then I would do the 2s the same way. 1, 2, 3, 4, 5, 6. The 3s. One, 2, 3, 4, 5, 6. And I'm sure the student would start to see the pattern, so I would probably ask them if they could finish the rest of them through 6. 1, 2, 3, 4, 5, 6. And then the 5s. 6. 6, 5, 4, 3, 2, 1. And then finally the 6s. And then showing the student this, they could see that there are 36 options instead of 6 because you would be multiplying 1/6 times 1/6, and as you can see there's only one option to get a pair of 5s, in which there would be multiple options to get other pairs, but since they're asking for a pair of 5s, it would be 1 out of 36. The second problem is, I'm going to change the page. The second problem is an experiment consisting of tossing tossing a coin twice. The student reasons that there are 3 possible outcomes: 2 heads, 1 head, or no heads. Thus, the probability of 2 heads is 1/3. How do you respond? The way that I would respond to this is the student is partially correct, but the student forgot the first flip, so you could show them by writing. They could get 2 heads is one option, 2 tails is an option, a tails and a head as an option, and a heads and a tails as an option. And although 2 of them look the same, they are resulting in 1 head, but they are 2 different sample spaces. So instead of the probability being 1/3, the probability is 1/4. For number 4, the probability of flipping a coin a certain times and getting a precise number of heads. For example, what is the probability of flipping a coin 3 times and getting exactly 2 heads? So, to do this one, you could make a tree diagram. And since they're looking for exactly 2 heads, you can't have any more, which would be a common mistake made by some students. So you could do heads and a tails, and then your second roll would be a heads or a tails, a heads or a tails, and then for the third one, heads, tails, tails. You'll do the same for here, heads, tails, heads, tails, and then you would have heads, 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 tails, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So then you could go through and find which ones have exactly 2 heads, which would be 1, 2, 3, and that is it. And the top one, heads, 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 does not work because you're looking for exactly 2 heads. So the answer would be 3 out of 8 because there's 8 options for it. So your probability is 3/8. For number 5, it says, what is the difference between a permutation and a combination? How is each computed and when is each used? So a combination or a permutation is an arrangement or listing in which order is important. So, compute using factorials. So if you have, for an example, if you have 5 bowlers, how can they be arranged? So it would be written like this is one way, or you could do it as 5 times 4 times 3 times 2 times 1. And then if you put that in the calculator, or you could try and do it mentally, there is 180 ways for the bowlers to be arranged. For combinations, it is an arrangement of objects in which the order does not matter. You compute using fundamental counting principle. So an example of that one would be, how many outfits can you make from 3 sweaters, 4 blouses, and 6 skirts? So since order doesn't matter, you could compute this any way you want, and you could also draw it out in a tree diagram. But writing it out, it would be, since you have 3 sweaters, it would be, this one's combinations, and it would be 3 sweaters times 4 blouses and 6 skirts. And if you multiply that, it is 72. But you could write it any other way. You could write 4 times 3 times 6. Or you could do 6 times 3 times 4, and you will still get 72 as your answer. Number 5. Next we have number 14. So be able to find the percent of any number mentally. For example, what is 6% of 210? So the easiest way to do this is to go by 10% in most cases, because that's the easiest number to find out of, like, mentally for a percentage. So you're going to try and find the most friendly percents that you can. So you'll start with 210, and the 6% doesn't necessarily matter right now. So 10% of 210 is 21. So then to get closer to 6%, you want to find 5% because that's half of 10. So you'll find 5%, so you'll half 21, which is 10.5. And then all you need is 1%, so you will find 1% of 200, you'll find 1% of 10.5, because it's easier to find the 1% out of a smaller number. So you're going to do 1% equals 2.1, and you can also find that by doing 210 divided by 100. And then to get to 6%, you will add the 5% and the 1%. So you're going to have 10.5 plus 2.1, which is 12.6%, or 12.6. So 6% of 210 is 12.6.